In this lesson, we will use law of sines to solve triangles. First, some important things to know. Law of sines is used for triangles that are not right triangles. The uppercase letters are our angles, and the lowercase letters are our sides. So look at the law of sines. Sine of A, that is an angle, just like every time you use sine, cosine, and tangent, you do sine of the angle, and it's going to be to the opposite side. So this little a is this side that's opposite. So here's our angle A, opposite. So angle A, opposite of that will be side A. And then we have a ratio of sine of B, so our angle to our opposite side B. And you really only need two ratios at a time in order to solve the proportion, but it also is going to be congruent or equal to sine of C and its opposite side C. Notice that law of sines can also be flipped over, which is the last point, that the law of sines is a ratio that is the side of the triangle to the sine of the opposite angle. The reciprocal of the ratios will also be equivalent. So it will not matter if you put your sides or your angles, so sides or angles, as the numerator or denominator, as long as you're using sine of the angle to the opposite side. So let's look at some examples. Number 1, in triangle CAB, we're given some information. We want to find the length of side C. We know that's a side because it's a little letter, to the nearest tenth of a foot. So we definitely want to remember rounding at the end. So first of all, our triangle CAB, we notice we don't have one, so just draw a three-sided figure. Do not worry about being exact for the measurements. These pictures will not be drawn to scale. So CAB, CAB, when it gives you the triangle name, just put the three letters in order around the triangle. So it doesn't matter where you start. I could have started here at the top for C and then A and B, but just do those three letters for the triangle's name. And then start labeling the measurements. 8 feet for side B, and we know that goes opposite of angle B. Angle B is 28 degrees, and angle C is 42 degrees. It wants us to find the length of side C. So this works out perfectly because in order to use law of sines, we have to have an angle and a side opposite as our given information. If we did not have that given information, we'd either need to find more information to use law of sines, or we'd have to use something else. But because we have an angle and the side opposite, just like sine in right triangle stands for opposite, we know we can use law of sines. We also have this angle and side opposite that we need to solve for. So let's set up our problem. Sine of our angle over the opposite side. So that angle side pair has to go together. And sine of our angle and the opposite side that we need to solve for that missing side. So like I said earlier, it doesn't matter if you started with sine of the angle and then the opposite side, or you could have had these ratios flipped over. We now see this is a proportion, so we can cross multiply. When you cross multiply, I recommend putting the letter or number in the front and then writing sine of your angle. That works best just in operation, so you don't accidentally take the sign of this number that doesn't need to be included with the sine word. So that cross multiplication, do 8 sine of 42. Again, putting that in the front, and you can say multiplication because that's what we're doing, is cross multiplying. So our last step is to divide by sine of 28, because those would cancel, leaving our variable by itself. So divide both sides by sine of 28. do not type anything into the calculator until you have your variable by itself. So now that it is by itself, we know we can say C equals and type this into our calculator. In your calculator, very first thing is to make sure it's in the correct mode. So hit the mode button and check that it is in degrees mode. So you can arrow down and highlight degrees and press enter. You can quit out of that menu to do your calculations. So we have 8 sine of 42 that we need to multiply together and then divide by sine of 28. Be very careful. Your calculator knows order of operations. So if you type it in literally just like that, 8 times sine of 42 divided by sine of 28, sometimes it causes you to miss the problem. So here's some ways to do it. The easiest is alpha y equals. When you set up alpha y equals and type it in exactly as you have it written, that is the best way to have the correct answer. So 8 sine of 42, we can close the parentheses, it's not necessary. And then in the denominator, sine of 28. So that is the easiest way to make sure you're going to get it typed in the calculator correctly. It does tell us to round to the 10th of a foot. I will show you another way that I tend to do it. I say 8 sine of 42. Go ahead and let the calculator calculate that value. We don't really care about it until we divide. So then I hit divide by sine of 28. I tend to not use the alpha y equals. So that gives us the same answer again that way. So just remembering to tell the calculator exactly what you want it to do, or else it's going to follow order of operation. So in our answer, we will have 11.4, and we are in the units for our side lengths, 11.4 feet. Let's now look at our next example. We have a triangle RAN, so we already know we're going to need to draw a figure since we're not provided one. RAN. Again, whatever angle you want to start with doesn't matter as long as you have those 3 letters. It says side A is 17 yards. We know that goes opposite of angle A. Angle R is 33 degrees. And angle N is 104 degrees. It wants us to find the length of side R. So our angle and side are opposite that we need to solve for, but we kind of don't have enough information to really set up this problem yet. We notice that we have a side opposite of an angle that we do not know the value of, or we have an angle and a side opposite of that we don't even need the value or have the value of. So we do have some work to do before we can actually set up law of sines. Because remember, you must have given to you the information of a angle and side opposite to use law of sines. Because I need this angle A, and once I had that, I would have the information necessary. If I find that angle, I can set up law of sines. Well, we know that the sum of all the angles is 180 degrees. So if I take 33 and add that 104, and then take that number and subtract it from 180, that will give us angle A. So let's do that now. We have 33 plus 104 gives you 137, and take 180 and subtract that 137, and we know now that 43 degrees is angle A. 137. Just so we can remember what our work was, we'll write that down. So this one is angle A. Let me write it in instead of having that angle symbol, 43 degrees there. So now we have enough information to set up law of sines because we have the angle and the side opposite as our given information. Let's start actually this time with our side. So I'm going to start with the 17 just to show you that it does work either way when you flip over. So 17 has to pair up with sine of 43, remembering always to put your angle measurement with the word sine. And if we're going to start with our side and go to our angle, we have to set it up the same way in the other angle side pair. So r over sine of 33. Once again, we'll cross multiply. So 17 sine of 33. And then r sine of 43. Because we're needing to solve for r, be sure that we move away the things that are here with the r. So because sine of 43 is over on the same side as r, that's what we're going to divide by. It's always trying to solve for the variable by moving whatever operations away from that variable. Sine of 43. So we will not type anything into the calculator until our variable is by itself, and it is now that way. So I'm going to type in, again, remember we can go alpha y equals and do 17 sine of 33 divided by sine of 43 and get that value. It does want us to round to the nearest yard, or I personally tend to do 17 sine of 33. Go ahead and press enter, but then don't forget to divide by sine of 43. Either way, you get the both same answers, but making sure that we tell the calculator the correct steps we want it to do. To the nearest yard would be a whole number. So here this 5 would make that round up. The rule is it has to be 5 or more to make it round up. So we'd have 14. R equals 14 yards. Let's look now at example number 3. Again, we need our triangle, so we have X, Y, Z. Again, not worrying about being precise in our drawings, just a three-sided figure since it has a triangle X, Y, and Z. Angle Z says it's 39 degrees. Angle Y is 67 degrees. And side Z is 28. And that's 28 centimeters. Again, we know that angles obviously are the larger letter, and it has the angle symbol, so that helps us. But we know this is a side because it is a small lowercase letter. So here we're actually going to find all the missing sides and angles. We'll round all of our answers to the nearest whole number just to be consistent throughout the whole problem. We're off to a great start already. 39, we have the opposite side, so we already have the provided information to even be able to use law of sines. Otherwise, we'd either have to solve for more information first or use some other method. Well, because we need to solve for all the missing pieces, let's go ahead and list them. We're going to need to find angle X. We're going to need to find side Y. And we're going to need to find side X. So we'll find all of those missing sides and angles. Well, let's go ahead and set up for a missing side. Since I have angle Y, let's go ahead and just set up and solve for side Y. So we set up sine of our angle. So I'm doing 39 to the opposite side. That's a 28. And that's going to be the sine of the angle to the opposite side. So again, I started with my sine of my angle, but you could have flipped it over. If you do, you got to make sure you flip over both of those ratios. So sine of 39 to the opposite side, sine of 67 to the opposite side, which is the one we're going to solve for first. When you cross multiply, we get y sine of 39, and then 28 sine of 67. Don't touch the calculator yet until our variable is by itself. So we're going to divide by sine of 39 on both sides. And we know to choose that because by dividing that value of sine of 39, it gets the variable by itself. So always pick whatever's on the same side as your variable. So here we find that y equals, and we're ready to type that in our calculator. 28 sine of 67, and then sine of 39 in the denominator. So rounding that, like it said, to the nearest whole number. So this is our ones place that would make it a whole number. We look behind. The 9 would make this round up. Because that is a 5 or greater, we round up to 41. And our units for this problem, we were in centimeters for our side lengths. So side Y will be 41 centimeters. Well, now let's move on and go ahead and find angle X, because in order to even find side X, we'll need that angle. So we can do the 180 and subtract the total of the angles that we already have. So 67 plus 39, that's going to give us 106. So actually, if we need to show, so you remember where that numbers come from, 67 plus 39 is the 106, and we're subtracting that from 180, just if you need to remember that in your work. So 180 minus 106 gives us 74 degrees, so that's going to be our missing angle X that we need. So let's fill that in our picture. So we're going to use this angle and side pair to solve for X. Now I know we did just solve for angle Y, and we could use that angle side pair now to set up law of sines. However, if we made a mistake in that work, it's going to cause us to also miss angle X. So I highly recommend sticking with the already given information. So the angle side pair that was given to you originally, so sine of 39 over 28, and then set up the angle side pair to find side X. Sine of 74 over X. We could have used the 67 with the value that we just found, the 41, but if you made a mistake in this work, it's going to guarantee you're also going to miss the next step. So I always recommend using what was given to you originally as much as you can. All right, let's cross multiply. So X sine of 39. And the other cross multiplication will be 28 sine of 74. And then we'll divide by sine of 39. And of course, we're choosing to divide by sine of 39 because it's on the same side of X, and that will get our variable by itself. So X equals, when we type this into our calculator, alpha Y equals 28 sine of 74. That did not work. Try again. There we go. 28 sine of 74 and sine of 39. Me personally, I don't tend to use the alpha Y equals. I know students do better with that though, so that's why I'm showing that way. We said we're rounding there as whole number, so this will round to 43 with that 7 there in the tenths place. It makes it round up. So 43, because this is a side of the triangle, our units are still centimeters. So we have 43 centimeters. And then now is kind of a good time to think about reasonability. Don't just move on when you solve your problems. Think back to, all right, opposite of a 67 degree angle, we had a 41. And the angle was a little bit bigger, so our side got a little bit bigger. So this is some reasonable answers. 39, think about, that's the smallest angle, so opposite of that was the smallest side, which was given to us. So yes, these are some reasonable answers for the values that we have in our triangle. One last problem, and this one actually is a more challenging problem, but we'll walk through it together. Number 4, we have 2 wires help support a tall pole. One wire forms an angle of 48 degrees with the ground, and the other wire forms an angle of 72 degrees with the ground. The wires are 20 meters apart. To the nearest tenth of a meter, how tall is the pole? So that whole situation was to get you familiar with the problem, but it also gives you the values that are already labeled in our diagram. So I hope you realize that this dark side of the figure is our pole that it's wanting us to find the value of. We will need to remember to the nearest tenth of a meter. So for our rounding on our final answer, we're finding how tall the pole is. If you actually want to pause the video, I'm going to use two different color highlighters. So if you want to get two different color highlighters or maybe ink pens, so we can look at some different shapes in this picture. So the first shape I want you to recognize is this right triangle. So if we just see this larger triangle, it is a right triangle, because we really have to assume that a pole is going to be standing perpendicular to the ground. Hopefully they're not building a pole that's going to lean over, especially because they didn't give that to us in the information. So if that is a right triangle and we were to find the hypotenuse first, we can use that to get to our height of our pole. So what I mean by that, we have this 48 degrees, again, just picturing that larger triangle, which is a right triangle. We have the 48 degrees. Opposite of that is x, and the hypotenuse, if I knew it, I could use sine of theta, that 48 degrees, equals x over whatever the hypotenuse is in order to solve for the value we need. So we can actually set that up once we find the hypotenuse. Well, we can do that by looking at another triangle. So this smaller triangle, so using law of sines in this smaller triangle, because it is not a right triangle, we can actually get to that length. We wouldn't really call it a hypotenuse anymore for this orange triangle, but because we've already labeled it at h, I'm just going to leave it as that so we know what value we're finding. This is not the only way you can solve this problem, so just know this is what I first see in the triangles. Feel free to try other methods to get to the solution. All right, so to work through this, I see that I have a side labeled 20. I definitely need the opposite angle, and that could be my angle side pair for my given information. Since I'm wanting to find this value h, I see that's a side that's opposite this angle that's right beside the 72. Well, the good thing is I can find that first off. Because I know they're side by side on a line, so let's just redraw this so you can remember. So if that's 72 degrees, we need to find this value here. Those are actually supplementary angles. So you can take 180 minus 72, and that will give you the value of that angle. 180 minus 72, 108. So that measure for this angle is 108. So that's a great starting place for law of sines because we have an angle side pair that's going to help me solve for that value h. But we said we also need this angle here at the top of the orange triangle, because if I had that angle and side, let's draw our opposite line there. If we had that angle side pair, that can be our given information, which even lets us use law of sines. Well, the sum of an angle of a triangle is 180. So let's show, maybe over here to the side, if we take 48 and our new angle we just found, 108, and add those together, 48 and 108, we get 156, and then we're going to subtract that from the 180. And of course, we're just writing this down so we can remember where we got all of these numbers from. That would be a 24-degree angle. So that is this here in the top, 24. Well, now we are ready to set up law of sines, so we can find that value of h. So sine, and actually let's not start with the sine since I've done several of those. Let's start with the side of our triangle. So let's start with the 20. Again, it does not matter. I just want to show you both ways so you can pick which one you like the most. So if I start with the side of the triangle, I have to go with the opposite angle for the sine of 24. So the angle side pair, they have to be opposite in order to use law of sines. So because we did the side and then the angle, we have to do that also with the other angle side pair. So h and sine of 108. Let's cross multiply to solve. So we've got 20 sine of 108, and then the other cross multiplication is h sine of 24. We will divide by sine of 24, and that will get our variable by itself. So we will be able to say h equals, and once our variable is by itself, we type all of that into our calculator. So we want 20 sine of 108, and then we're going to divide that by sine of 24. So it's wanting us, because this isn't our final answer, we can just kind of choose how we want to round. I'm going to just go ahead and stay consistent with the tenths place. You could always use more decimal places to be even more precise. We're going to just do the tenths since with our final answer is that way as well. 46.8. And we are in meters for that. So that is for the h. Since we saw the right triangle from the beginning, so we're going to go back to that pink triangle and let's set up sine, and we can use that because it is a right triangle. So that's going to help us solve for the height of the pole. So sine of our angle, so we have to use 48, equals opposite over hypotenuse, and we did just find that 46.8. When you solve these, you always multiply by the denominator, so we're going to take 46.8 and multiply both sides. $46.8. I just rewrote it so you can see what we're doing there. I'm multiplying by 46.8. And so we, again, don't touch our calculator until our variable's by itself, which it is now. So x, which is the height of our pole, is going to be 46.8 times sine of 48. So 46.8 times sine of 48. So that gives us 37 point, because we're still rounding to the nearest tenth, 34.8. And we are in meters. So how tall is the pole? The pole is, we could say approximately since we knew there was some rounding, but the pole is 34.8 meters. Again, that is not the only way you can solve that. You can look at different parts of the triangle, maybe possibly even just seeing the smaller triangle and working through that. But this is the way I see and visualize these triangles, so it does help us solve for that measurement.